Hi everyone, thanks for joining us for this session on embodied carbon in lighting. I'm Leela Shanker from the Flint Collective NYC. Definitely missing being able to do this in person with everyone at LEDucation for the second year in a row, but I hope everyone's been taking good care.
Yes, definitely. Hello, my name's Elaine Cook from Moxie Lighting. Let's get through this presentation, Leela, shall we? So this is an AIA accredited presentation. For that, I have to share the 4 key learning objectives. The first one is gain an introduction to the key concepts, appreciate the need for the industry standards around embodied carbon, overview some of the data gaps in the current lighting metrics, and provide insight into international progress on how circular economy works in the lighting industry. So we are breaking this presentation down into 4 key categories: key terms to know, why embodied carbon matters within lighting, life cycle assessment data, and where next, what now. As I said before, my name is Elaine Cook. I originally from Canada, where I graduated with a Bachelor's of Engineering Science in Mechatronic Systems Engineering and a BA in Honors in Business Administration. I moved to New York City in 2019 to work for Moxie Lighting on their specification sales team, and I've been loving it ever since. My passion for embodied carbon actually started when I moved to New York in 2019, when I was trying to figure out New York City's waste management system, i.e., do you guys recycle? Is there a compost system? And actually through that research, I joined the AIA's COAT committee, which is their committee on the environment. And through one of its subcommittees, the Embodied Carbon Network, which is now called the Carbon Leadership Forum's New York Hub, did I understand the importance of embodied carbon and how it could impact our industry.
I'm Leela, a Chinese Indian Australian and citizen of the world. I studied a Master of Architecture and a Master of Fine Arts Lighting Design here in New York at Parsons. And I previously came across from Sydney with a Bachelor of Law and a Bachelor of Commerce. I'm a lighting designer and founder of a non-profit art and design collective that looks at urban interventions and the quality of public space, transforming it with light. And it was actually while I was thinking about bioluminescent facades and a different experience of the city if we had alternate sources of energy and different light levels that I started to really feel strongly about the fact that the conversation around sustainability in lighting is bigger than retrofitting with LED lamps. So really came to this field of embodied carbon in lighting while I was working as a lighting designer within WeWork, alongside Megan Lewis in the sustainability team, who's now at the Carbon Leadership Forum, and Star Davis and Michael Day from the Global Lighting team as well. And one of the things that I really love about working with Elaine at the Carbon Leadership Forum New York chapter and the AIA's Committee on the Environment is that we come to this conversation with different perspectives from design and manufacturing. And that's really translating because putting this discussion today about embodied carbon in a broader context, this dialogue is happening at a wider industry level across manufacturing and design, really with a lot of people interested in applying sustainable and circular economy principles to our industry. And to that end, the Green Light Alliance has formed this year to light up the world without depleting its resources. And it's a community of individuals, businesses, and institutions that are all interested in working together to share knowledge, systems, standards, and help each other develop the application of circular economy principles to the lighting industry. And it's really here to facilitate progress, not necessarily adjudicate between the many different people doing amazing work right now. But it's really just to highlight that there is a lot going on and that sometimes people don't know of each other. And with this central hub to communicate through, we can actually be more efficient with our own time and energy in progressing the movement. So, to get into the conversation, let's pick up some of the language. Of course, understanding that today's session is very specific in focus to embodied carbon, which is really about a kind of measure of carbon emissions that's not related to operational energy consumption. there's really a lot of acronym soup going on, which we're trying to just skim over today in the short time that we have. And we can always dive in with more detail if you have questions later on. So there's the circular economy, which you'll hear a lot about, which is a big picture economic system approach. Then there's the methodology, life cycle assessment. And then there is the reports and the rules to apply that methodology, which is the product category ruling and the environmental product declarations that apply those rules. So first, circular economy. Stepping back at the way we've been producing goods and providing those goods to consumers, if we look at the traditional linear economy, that really looks at extracting minerals and resources from the ground, and these materials having a kind of one-way ticket through manufacturer, distribution, use, back into the ground potentially as waste. When we think about the circular economy, we actually start to find out how we can recapture some of these materials in their raw form, or use components of goods again, or the actual products themselves having a longer lifetime or a second life, and making sure that there's less that ends up in waste. And all of that feeds back into the system of production and consumption. Then, what do we mean by embodied carbon? So we're talking about greenhouse gas emissions, and the lighting industry has really focused a lot, and rightly so, on operational carbon, which is the emissions associated with operating our buildings, turning the lights on effectively. And that's where a lot of the targets and metrics like lighting power density have come into play and been understood internationally. But if we look at embodied carbon, that's taking a fuller picture of emissions associated with other parts of the life cycle of products, which is, producing the product to begin with, and transporting the materials and the products around the world to wherever they're assembled and then wherever they're used, and then transporting them on from installation to wherever they lie at the end of their life for maintenance or disposal, and potentially recycle. And that feeds into this idea of really understanding the full life cycle of a product or a lighting system through life cycle assessment, which is a way of tracking emissions that are released into the air, water, and soil that affect the environment over that full cradle to gate or cradle to grave cycle. And in the lighting industry, if we move through product construction all the way to cradle to grave, what we start with is explode the fixture into all its component parts and think carefully about where we're getting the materials to create each component. The image we have there is all of the components of a spotlight, which was the subject of investigation by Greta Smith-Newt and Matthew Capes-War in a recent study that they published at PLDC in Singapore and Rotterdam over the last couple of years. They're from Michael Grubb's studio, and it was really interesting research getting specific about how we could potentially apply sustainable design to this one fixture. And tracing across more of their work, you can follow how there's so much movement around the world, even for the various components to start to arrive from Asia to Europe, where they may be further processed, to another part of Europe where they may be assembled. And that's even before they leave the manufacturer, which is the gate, as it's called. And then the stage that we mentioned before, which is more about operational carbon, is associated with the usage when the fixtures are installed in a building. And a lot of the conversation is, of course, about efficiency, and with LED technology improving in efficiency, that's been a lot of the priority to look at. But we can do more, and this is not the phase that's really the focus of embodied carbon investigations. But we do look at what happens after use and how these materials end up being transported to landfill or deconstructed. So that's the grave, as they also call it, or they can be used again or recycled. And there are various schemes that you may be familiar with, like NLR, that allow you to recycle ballasts or lamps or various particular pieces of those. So that's the overarching assessment, life cycle assessment. Then the product category ruling is really an agreed process. So as we all know, even with something as simple as a martini, where there's very few components and one would argue not very many steps, there's still a lot of interpretation that goes into any particular recipe or method or process. And so when we, so in this case, of course, do you have the olive excluded or included? Is it shaken or stirred? Not to oversimplify it, but moving to the context of a life cycle assessment in lighting, we actually do have, and we go to the next slide, an example of an existing set of rules that has come out of Europe with the PEP Eco Passport program that is specific to luminaires and can take a functional unit, which is a benchmark for what is considered standard approach to a particular process of analysing the life cycle of a luminaire. And in this case, for example, they're looking at a luminaire with 1,000 lumen output and a lifespan of 35,000 hours. So once you have the rules set, then you can come to product-specific reports, which are environmental product declarations. And continuing the martini discussion alongside our lighting discussion, you can see here there's a specific execution of the method, which in the case of environmental product declarations becomes effectively like an environmental spec sheet. And we've included here the data that's come out of one manufacturer's leading publication just a few weeks back this year. This company, and we can't mention it, but we can afterwards if you want to follow up with us, just because of the AIA rules, we end up finding that companies who have really believed in this sort of assessment and data have been doing it for quite a while, even as early as 2013, commencing on the collection and analysis of data. And what you'll get from it is a number of different metrics that explain the impact on the environment. What we really zone in on is the global warming potential, and we'll come back to that in some detail later, but it's interesting to note that these analysis decisions, or the decision to commit to doing these EPDs, can be led from anywhere. In this case, it was led from Australasia, and the life cycle assessment was completed with a team of experts on LCA in New Zealand.
So, but why does this matter? Why does embodied carbon have to do with saving the world from global warming? We have broken this section down into 3 sections: operational versus embodied carbon, legislative requirements and incentives, and market demand. Before we dive directly into the lighting industry, I wanted to back up and connect how embodied carbon, with the environmental goals that we have taken. So the Paris Agreement was adopted in 2015. The goal is to limit global warming to be below 2 degrees Celsius, preferably to 1.5 degrees Celsius. From countries we do have data on, only 8 countries are compatible with these goals. And unfortunately, the US is one of the worst performing countries. The United States is only second to China for the most CO2 emissions in the world. The US produces over 6,000 million tons of CO2 each year, which is 12.67% of the global greenhouse gas emissions. In order to reach the Paris Agreement goals, we need to reduce our emissions by 7.6%, which looks like over 450 million tons of CO2 each year. Out of the 9 categories for America's emissions, the top 4 emitting sectors make up more than 80% of the total emissions for the US. As you've probably noticed, the A&D community can directly affect all of these categories. When looking at the emission breakdowns for New York City, however, the breakdown is actually a little bit different. 66% of New York City's emissions is from buildings directly, 30% is from transport, and 4% is from waste. And that's why New York City has taken very aggressive goals for trying to save our world from global warming. New York City signed one New York City 2050 in 2017, committing the city of New York to be carbon neutral by 2050. A huge part of New York City's plan is to source 100% of its energy from renewable sources. But with 66% of New York City's emissions coming from buildings, they've also implemented citywide energy efficiency and intensity mandates. This is the breakdown of the building industry or buildings in New York City and their emissions. So 66% of New York's emissions come from buildings. 20% of those emissions come from multifamily homes. Another 20% come from the commercial buildings. Lighting for multifamily homes make up 5% of the total emissions, and in commercial buildings, it makes up 16% in commercial. If you multiply those all together, it actually comes out to 139 million tons of CO2 that is emitted just from lighting within New York City. Now that we kind of put that into context of just operationally how much our industry impacts the environment just in New York City, we're going to dive into how embodied carbon also has a very big impact.
So yeah, acknowledging that those targets are hugely ambitious and we've got a big job ahead of us, every little bit counts. And when we start to project forward as to the relative importance of embodied carbon versus operational carbon, the statistics are very interesting that if we just continue as on business as usual, the global new construction projected by 2060 will mean we've doubled the square footage of building we currently have. So our choices in what materials and suppliers we're actually using is important. And what you can see here is that by 2050, the embodied carbon will actually form up to 50% of the carbon footprint of these new buildings. So we should be thinking about it carefully. And another thing to engage with is the nature of embodied carbon being an amount of contribution or emissions that doesn't really change over time because it's associated with the production of these products, whereas increasing efficiency in technology can actually reduce the increase potentially, or the rate of increase of accumulating operational carbon. So whilst we think about production, it's actually really important to understand how we're designing and really using these processes of manufacturing carefully, because the end of life cycle will actually only operate as effective offsets in emissions compared to the production side of the life cycle. But yes, jumping straight into a study that the Carbon Leadership Forum actually led, investigating at one of WeWork's locations in North America in 2019, we looked very specifically at the impact of different sectors of building material within a commercial office space. This space has had about 79,000 gross square feet and 1,370 desks. And what we found was that when you actually do look at both the production stage A of the life cycle and the end of life stage C, the global warming potential of lighting was significant compared to many other categories of cost areas like painting, plumbing, and so forth. And even more specifically, LED fixtures were found to be one of the highest impact items, and therefore it justified us, off the back of this study, doing further study into particular fixtures with our manufacturing partners. So how is this feeding in around the world and into existing schemes to acknowledge the importance of embodied carbon? Well, we would all be familiar with many of these green building initiatives. And just to name one, for example, LEED is giving credits for using suppliers or products that have environmental product declarations available. But even more specifically for the lighting industry, there are rating systems being developed like the Lighting for Good framework that allows for transparency and acknowledgement of particular suppliers that are taking a positive approach to the life cycle assessment process. And we'll come back to that.
Other industries within the A&D community have already started to draft and get legislation passed that will incentivize manufacturers to develop low carbon products. The Open Air Collective is one of them. It is an advocacy group that recently drafted and recently got passed both in New York State and New Jersey, the Low Embodied Carbon Concrete Leadership Act, LECLA, that operates within the public bid system. LECLA is an incentive for concrete producers to incorporate low carbon alternatives by giving them a discounted dollar rate based on their EPD score. This allows bids with really good EPDs to be considered less expensive than they actually are. This is a simple yet brilliant system that can be easily copied into the lighting industry to provide incentives for manufacturers and their salespeople to use low carbon products. I actually set up an example to run through on how this could work within the lighting industry. On the left-hand side is our EPD scorecard and the respective discount rates. Fixture A and fixture B are the exact same fixture performance-wise. The only difference is that fixture B has a better EPD and a higher starting price. Fixture A's EPD score is too low to get a discount rate, so its price stays at $100. Fixture B's EPD score is higher, so it gets a discounted rate, and that equals out to about $88. This is a very simple example, but we wanted to showcase how this could work within the industries, and it's actually already been included in countries like Europe, or countries within Europe, and it goes to show the effectiveness of a model like this. So the market demand for embodied carbon. Who was asking? In the past year, I have been asked by multiple designers to get EPDs for my fixtures. Lighting firms and engineering firms like Arup and Bjork Happold are writing in-house policies to factor EPDs into their design process within lighting itself. I have architects asking for EPDs almost on the weekly basis to gain credits for green building schemes. Over in Europe, government work, you already have to provide an EPD or provide competitive credits for companies with EPDs. There are manufacturers out there in the lighting industry with EPDs, but they're not standardized. So for a designer, it's kind of like trying to compare apples and oranges. This is why we're continuing to work with so many allies like AIA's COAT committee and the CLF and UL to make sure that we have a standardized format so that designers can easily read this data and compare different fixtures.
And similarly, the fact that these networks for sharing information and creating standards are developing now, like the Green Light Alliance, really shows that there is momentum behind this. And there are many designers, manufacturers, educators, compliance schemes, media associations, and standards bodies, as well as industry associations and particular initiatives who want to be part of that conversation. And that's really proof that this is something that is and should be pursued at an international level. And if we look at a specific system, again, diving into the Lighting for Good rating system, it's an example of one framework, and there could be many others that develop over time and may already be in existence as well. But it is proof that there are corporate leaders in this space. This particular scheme came out of a think tank started by LVMH with over 25 of their lighting suppliers in 2018. And they came up with this charter, which looks at the full life cycle of lighting products. So it does include usage, but the aim was really to address circular economy issues, maintenance and removal of plastic from the industry, and was very intentional to go beyond the current legislative framework from the European Commission. So people are being bold, and there are these rating systems that are coming out as a result, which is very exciting. And what we would be well placed to understand is how they all feed into each other and support each other. So how would an environmental product declaration or the data that comes from that feed into this rating system or others is a conversation that is worth having. Similarly, we have other associations from related disciplines in construction really asking for embodied carbon to be regulated. So for example, the Architects Climate Action Network in the UK has started this embodied carbon campaign. So they are the people who employ us and ask for information of us too. Similarly, there are very established industry associations that are developing standards and calling for more data. So the Chartered Institution of Building Services Engineers and Elementa collaborated to publish just in January this year, Technical Memorandum 65, which is giving manufacturers a survey effectively to fill in the data that they have about their particular products, MEP products, so that we can develop more of a database of good information to compare products that may not even have their own official EPD, but we will still be able to look sensibly across particular types of products.
So you're all probably wondering how complex a real life cycle assessment is. This is a typical pathway taken for an LCA or EPD. Fabricators, aka our lighting manufacturers, compile the data on their product. This is then organized through an LCA and is used to create an EPD. This simply can be looked at as data in, data out system. Manufacturers supply the product data, and we split out the required data for architects and designers to use. For the data in, this is all product data. There are multiple ways for someone to get this information. The first is straight from the source, the manufacturer, but sometimes the manufacturer either doesn't manufacture all of the components, or so they have to rely on supplier data, or they can rely on industry databases. Or there's another way to do it. We could also go to the LCI database, which is the life cycle inventory of the United States. And that is a database of standard products and things like that. For data out, it's quite simple. It is an EPD. This goes directly to the designer so that it can be put on project submittals. An EPD can also go to a publicly accessible EPD database so that more people can find this information. This slide, or the last slide, really only concentrated on cradle to gate life cycle, where this slide really focuses on from cradle to grave. I could spend a full hour just discussing this slide itself, but for this presentation, we really want to focus on the product stage. So the list on the right looks a little bit scary, especially for the manufacturers who are probably like, I have to get all of this data. But when you dig into it, a lot of this information has already been collected, and we just need to kind of dig our teeth in just that next little level. Right now it's broken down into essential information, mid-level information, and further information. The goal of this process is not to cost the manufacturer time and money, but to actually save it while reducing the company's carbon footprint. I have worked with manufacturers who started work on this without a formal EPD, one of which was located in Canada, and around 2 to 3 years ago, they completely redesigned some of their top fixtures based on the fact they wanted to reduce their carbon emissions of those fixtures. You can see one of the fixtures blown up over here. We were able to reduce the amount of material used within this fixture by 20%, and decrease production time by 10% by just looking at the fixture through the lens of wanting to reduce its overall emissions. If you can't convince your boss to look at it as an environmental standpoint, the savings might be a way to convince them to go through this process. The essential information required is basically the material used of the product, its weight, the production equipment used, and its energy usage, and the total factory energy consumption. The material used in weight is very important because each different material has a different carbon footprint when we are trying to take it out of the ground. The production equipment used within production should be something that can be easily found, but if the factory is not set up to monitor its energy usage from those machines, it might require a slight investment to get that those monitors. The energy usage of the facility is basically taking account the carbon produced by the manufacturer outside of the production side. So offices, where they're located, everything like that, so that a portion of that carbon emitted by all of those different offices and places can be tacked on to the emissions for the total fixture. So mid-level information. This is something that is probably in most of the manufacturer's records already. The annual energy consumption will be totaled from the monthly bills that we get in the mail. They're usually not small. The quantity of the product produced will be a number that the operations team should take track of, but if not, the VP of sales probably definitely does. Your supplier manager will know where your suppliers are individually, but where problems could arise is if the manufacturer's suppliers information isn't well documented or known or cannot really be trusted. And in these situations, the databases that I mentioned earlier are really helpful so that you can go and find similarly listed products to that specific subcomponent and use that in the preliminary assessment. Where it becomes a lot more work is where it is within the further information. Excluding cost and warranty, as you should probably already have that information on your spec sheets, it becomes a little bit harder to dive into some of the other ones on the list. But I think if you look at it on more of a bite-sized information way, it becomes a little bit more manageable. Maybe you just look at one product that you're wanting to look at how it can be reused and take that one product and dive into that. Or you take that one product and you find out why the fixture fails at the end of life and replace that specific component that fails within the fixture itself, allowing your customer to order just that specific component rather than having to buy a completely new fixture. And now I'm going to pass it over to Leela.
That's a lot of data in, and then putting it through the life cycle assessment machine, if you like, it spits out a whole bunch of new data, which is really greenhouse gas emissions, so kilograms, as I can put it from a metric land, of various gases like CO2 for global warming potential, CFCs relating to depletion of the ozone layer, certain chemicals that will actually lead to smog or reduce the quality of breathing air, the impact on ecosystems, and also the degree to which they're using non-renewable energy resources. And all that to say, this data is fascinating, sexy, but what do we do with it if we don't have consistent approaches to be able to compare? And by that, we then need to move to industry benchmarking and filling in some of the data gaps. So what we really ultimately want is reliable, consistent, complete, auditable, accurate data. And it starts with doing an industry pilot and deciding which types of luminaires we really want to collect data on to begin with, so that we can, as Elaine said before, compare apples with apples. So, for example, are we really wanting to compare a 4-foot linear beside a cylinder beside a street pole? Probably not. We want more data to decide to be able to compare in those separate categories. But then also how we conduct the life cycle assessment is something we have to agree on as well. There are a lot of questions about where we should have the functional unit defined. And as we mentioned before, there is a European precedent that we could follow in North America. But as much as possible, we want to have a global approach so that it's consistent and tweaked for different regions. And that involves making calls on lifespan, output, and many other elements of the methodology, which we can go into later. But then also there is missing data or substitute data that needs to be fed into this analysis as well. And the more manufacturers and partners we have on board to build the lighting database effectively, the better, because there are questions around, for example, how we quantify energy consumption in different locations. There are materials that simply haven't been involved in the data collection process before, or as Elaine was mentioning, some of the facilities that will be providing information may not be reliable. But then the only thing is to really roll sleeves up and get in there. So if we keep sharing information and really approaching the creation of standards in a collegial way, we really do have the potential to move forward as a climate competitive industry. And of course, wanting to do that as much as possible in an international context. So bringing it back though to the current status of what's happening here in North America, the first step is really trying to get a product category ruling that we can rely on. We are in conversation with UL to get an addendum to the PEP Eco Passport European precedent. And that will give us a standard methodology to take us on to doing an industry-wide environmental product declaration. And that is something that we are working with the Athena Sustainable Materials Institute on. And we would love to speak with all of you here and beyond this session about which products, how many manufacturers can be involved, and how wide we make this initial scope. And once we have that industry benchmark, then it makes good comparative sense to actually do individual environmental product declarations that can feed into our decision making a lot better. And of course, all of this takes participation from designers and manufacturers.
So let's keep the conversation going after this presentation. On the manufacturing side, I don't want you to feel overwhelmed by the list that I went through for what seemed like probably forever. The data, it is going to be hard to get started, but once we get started, it's going to be an easy process to get the whole industry on board. Manufacturers, if you're wondering where to start by having a conversation with your team and start collecting data or start looking into the data of your factory. Participate in industry EPDs, pilot projects, publish EPDs once we do have an LCA and an EPD, and share knowledge within the industry. I know there are some things, there's some trade secrets that you don't want to let another manufacturer know or anything like that, but still having a dialogue on how to generalize how we're going to get all of this information into play into the industry rather quickly.
And if you're a designer, there's really two things, know your palette, know what the impact is of all the different tools that you have at your disposal, and align with suppliers who share your values. So ask for the embodied carbon information from people you're working with. That will spur on the demand for this sort of analysis to occur, and ask what's happening to fixtures at the end of their life. There's legislation coming in that may put the burden back on producers to take responsibility for their environmental impact and emissions. We'll see where that goes. But similarly, thinking about how awareness of these concepts could feed into design curriculum is important as well. And then of course, being part of these networks that are sharing information and working towards standards is a huge part of us moving forward together.
And this presentation took a lot of background knowledge and research, and here are references for those that were involved within the presentation. And one thing that we just want to end on is that within a world of remote working, we are no longer facing this problem alone as just Americans. We have tons of people all over the world coming together to help us fight climate change and fight it within the lighting industry. We have initiatives, we have the associations, but now we just need to get the standards that fit within the North American market on both the design and the manufacturing sides. We need to develop the compliance schemes and develop the education plan for both current and future students, as well as professional working professionals.
So to kick off our live discussion, we leave you with a well-known quote from American cultural anthropologist and New Yorker, Margaret Mead: "Never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it's the only thing that ever has."
Awesome, so let's start chatting.